Okay, I believe I am recording. Make sure I got sound. I do. Okay. In the following exercise, find the value of k's that makes each function continuous. Right. So, interesting. So what's going to happen here is it switches from this line to this line at the point k. I don't think the 8's too important here. So we have to make sure the k is such that where this finishes, this one begins. So I can achieve that by just saying 3k plus 2 equals 2k minus 3. So that means k will equal minus 5. That should do the job. In fact, I can check the answers here. This is question 145. Let's see if we're right. Minus 5 is correct. Now, 0 to pi over 2, pi over 2 to pi. Yes, so this time we got to make sure when it transitions, it does so continuously. So that means sine pi over 2 will equal cos pi over 2 plus k. But sine pi over 2 is 0. So what that means is I just need this to equal 0, which means pi over 2 plus k. When is cos 0? Oh, I'm sorry, I said sine pi over 2 is 0. That's not true, it's 1. So that means I need this. So sine pi over 2 equals 1. So that means I need cos pi over 2 plus k to also equal 1. And k equal minus pi over 2 would do that. I mean, there's going to be more than one answer, but that's just one possible answer. Yeah, that would do it. Okay, cos of 0 is 1. Now this one's interesting. This is going to be a removable discontinuity. And so if I just factorize here, x plus 2 times x plus 1 over x plus 2, you can see that when x goes to minus 2, this is going to go to minus 1 as x goes to minus 2. Effectively, these cancelled out. So the k would have to be minus 1 then, I think. Let's check. Yep, minus 1 is correct. Correct. Okay, we got to make sure that e k times 4 will equal 4 plus 3 as it transitions from one piece to the other piece, which is, of course, 7. So that means 4k has to equal log 7. So that means k has to be 1/4 natural log 7. And finally here on the transition, 3k will have to equal 3 plus 1, which is 4, which means 3k has to equal 16. So k has to equal 16 over 3, which is also correct. Wonderful. Okay, that's that batch done. In the following exercise, use the intermediate value theorem. Let h equals that over the interval 0, 4. There's no value for x such that h... Okay, let me copy these over first. Okay. And clear this off. Okay. That's h over the interval 0 to 4. There's no value of x such that hx equals 10, although h0 is less than 10 and h4 is more than 10. Explain why this does not contradict the IVT. So what's happening here is that for the x, we have, what is it now? 0 to 4. And h0 is less than 10. We could actually calculate it. H0 is minus 4. And h4 is 20. So that would make us think that there should be some point. That means there should exist some point x0 in 0, 4 such that f of x0 equals 10, because the 10 is in the set minus 4 to 20. The reason it doesn't work here is because f or h is not continuous. H is not continuous in 0, 4. So the limit as x tends to 2 from the left of hx, that would equal 8. And the limit as x tends to 2 from the right equals 13. So there is a jump at 2. In other words, it does not exist a limit when x tends to 2 of h of x. And 2 is in 0, 4, so it's not continuous in 0, 4. So that's why it doesn't contradict it. Okay, a particle moving along a line has at each time t a position function st, which is continuous. Assume s2 equals 5 and s5 equals 2. Another particle moves such that its position is given by ht equals st minus t. Explain why there must be a clear value of c such that hc equals 0. Okay. So hc, we want that to equal 0. Okay. Which means that st minus t, or I should rather say sc minus c equals 0, which means that sc must equal c. Now, note c must belong to 2 to 5, and sc also belongs 2 to 5. So that means there, by the IVT, there must exist, maybe I should call this C0 so not to mix it up. There must exist a C0 between 2 and 5. Such that SC0 equals C0, and this C0 is our choice from also this 2 to 5. So, oh, I should be, I should make this one open, shouldn't I? Because we know that it's not going to be 2 and 5 that gives 0. So, but note again that S2 does not equal 0 and S5 does not equal 0. So that means the C0 must be between 2 and 5 then. I can't remember if for the IVT, if the set has to be open or closed. I better check it here. Yeah, it's closed. Yeah. Okay, I'm sure I could write that proof a little bit more elegantly, but oh, it's an odd one, so the answer would be at the back. 151. Yeah. 152. Use the statement the cosine of t is equal to t cubed. Write a mathematical equation for the statement. Oh, okay. Oh yeah, okay. So they want us to use okay, so we can use our calculator. We don't need to open up software. So cos t equals t cubed. Prove that the equation in part A has at least one real solution. So this is if we say let, so this is B now, let ft equal cos t minus t cubed, then we're required to solve, I guess, ft equal to 0. It's the same thing as solving part A. So note, okay, so I just need to find value that's positive and negative. Note that f of 0 equals 1. Because cos 0 is 1. And then f of 10. Let's get my calculator out here. Cos 10 minus 10 cubed. That's roughly minus 1,000. So the IVT means that there exists an x in 0 to 10 such that f of x can equal a number of our choice from 1 to minus 1,000. Okay. Use a calculator to find an interval of length 0.01 that contains a solution. Okay, so now I definitely need to use some software. So we know the answer is somewhere between 0 and 10. We want to do a little bit better than that. Okay, so I have to clear this off to make a bit of space. Let me just grab that. Didn't copy the text. That's weird. Okay, well let's open up our software. Can try and do this. Okay. ft is defined as cos t minus t cubed. I should say t. Okay. Yeah. All right. I want to plot it maybe. That might be illuminating. Let's go with minus 5 to 5. Again with my letters. Looks like it's a little bit after 0. Let's go with 0 to 1. Okay. 0.85 to 0.95. Okay. Looks like it's around about 0.87. Have a look. A little too big. Okay. Whoops. Okay. Right. We're honing in on it. This looks like it's 0.864. So we'll go with 865 to 8. Now I could just solve the equation, but I feel like that's cheating. I feel like that's not in the spirit of what they want in the question. Okay, how precise do they need this? 0.01. Have I achieved that? I've probably gone over, actually. 0.01. I've gone too precise. 8.6 to 8.7, I think will do just fine. Yeah. So if you calculate f of 0.86, then f of 0.87. So let me take out the calculator. So 0.86 that's a positive number. And then we confirm. Then 87. That's a negative number. So therefore, there's some root between 0.86 and 0.87. I wonder now, is this odd question? No, it's not, so there's no point in looking at the back. Okay. 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 And then lastly, I now have to clear this off. 153. How am I doing for sound and time? Yeah, okay, we've finished with this one. Apply the IVT to determine whether 2x equals x cubed has a solution in one of the intervals. Briefly explain the response. Okay, so let f(x) equal 2x minus x cubed. F of 1.25 equals f of 1.375 equals 2 power 1.25 minus 1.25 cubed. So that's 0.425, and then 1.375. And that's minus 0.00593. So that implies there exists an x in the interval 1.25 to 1.375 such that f of x is equal to 0, since I can choose 0 since 0 is in the interval minus, oh, I ran out of space, since 0's in the interval minus 0.006 to whatever, 0.4 or whatever you rounded off. Doesn't matter really. By IB, intermediate value theorem. What about this one? Now we need to calculate f of 1.5. F of 1.5 is negative minus 0.546, etc. So what that means is there exists an x in the interval 1.375 to 1.5 such that f of x equals y, where y is in the interval of minus 0.00593 to to the other value, minus 0.546 ... So the problem is that this doesn't include 0. Doesn't mean that it doesn't have a root, because I could graph it. Let's see what's happening. 2 power x minus x cubed. Plot 2 power x minus x cubed from 1.375 to 5. So it's monotonically decreasing, so it doesn't have a root. And I wonder what it says at the back too for 53. Applied. Oh, yeah, okay. Applied. Okay, so I guess the question is saying that the solution will be in one of the intervals. If that's the case, then therefore, if we must choose, we choose the first one, because the signs are opposite. One end is a positive and one end is a negative, meaning we can choose 0, and we know that there's an x solution here, also because this is continuous as well. So yeah, okay. What's up next now? Okay, still a good bit more to go, actually. Still a good bit more to go. But that's enough for today. So we'll wrap it up for there. Thanks for watching. Any mistakes or problems, please let me know in the comments, and I'll see you next time.